In this video, we'll understand about the basic property of electric charge. So, what are the properties of electric charge? The first property is electric charges are additive in nature, means you can add them just like scalar. That is, the total charge of a system Q is the sum of the individual charges in it. Let's say Q1, Q2, Q3 and Qn are the charges inside a system. Then the total charge of the system Q is given as the algebraic sum of all these charges. Let us consider an example. Okay, there is a system in which there is plus 10 coulomb, minus 2 coulomb, plus 3 coulomb, minus 6 coulomb. So if I want what is the net charge of this system, then what I will do, I will simply add these charges algebraically. That is plus 10 coulomb, plus 3 coulomb, minus 6 coulomb, minus 2 coulomb. That is 10 plus 3, 13, minus 6, minus 2, which is equals to 5 coulomb. So the charge of a system is equal to the sum of the individual charges present in that system. Now let us consider there is a system in which there is Q1 charge and Q2 charge, and if this sum is 0, then it implies that these two charges are of equal magnitude but of opposite polarity. Like there is a system minus 5 coulomb plus 5 coulomb. If these two charges will be equal and of opposite polarity, then only their sum will be 0. That is, if Q1 plus Q2 equal to 0, then these two charges are of equal and opposite polarity. Then second important property of charges is electric charges are quantized. Now what is the meaning of quantized? Quantized means a system can be varied by a particular unit. For example, pen. Okay, for example, pen. I can ask you for 1 pen, 2 pen, 3 pen and so on. But I cannot ask you give me 1.5 pen or give me 1.7th of a pen. Okay, so means a pen can be vary by 1 unit only. Okay, like the same, the charge of an body can be varied by unit of basic charge E. Okay, so electric charges are quantized. It means that the total charge Q on a body is always an integral multiple of a basic charge E, that is Q is equals to NE, where N equal to 1, 2, 3 and so on. Means suppose a body is getting charged, then either it will lose 1 electron, it will lose 2 electron, it will lose similarly n number of electron, but it will never lose 1.5 of electron, 1.6 of electron, 1.7 of electron, because electron is a fundamental particle, it cannot be divided. So 1e, 2e, 3e, like this electrons can be transferred from one body to another body. Okay, where n equal to 1, 2, 3. Okay, n equal to 1, 2, 3 and q is equals to ne. So 3 by 2e, 0.5e, 1.5e, all these charges cannot exist in nature because these are not integers, where n, you can remember that n equal to 1, 2, 3 so on, these are integers. Okay, so only integral value are possible. Now next part is conservation of charge. It is the important property of electric charge that charges are conserved in nature, means charge can neither be created nor be destroyed but can be transferred from one body to another body. For example, sodium chloride. sodium chloride, NaCl. When it is converted to Na plus and Cl minus, you can observe that before the reaction NaCl, it is a neutral crystal, so its charge is 0. After the reaction is over, we are getting Na plus ion and Cl minus ion. Na plus ion has a charge of plus C, Cl minus ion has a charge of minus E, that is negative and positive. So net charge after ionization is plus E plus of minus E, which is equal to 0. Hence left side is charge 0, right side also sum of the charges is 0. Hence charge is conserved. Now how this charge is different from mass? Okay, let's see. Charge may be positive, negative of 0. Okay, positive for proton, negative for electron, and 0 for a neutral object. But mass of a body is always positive. The charge is independent of speed, means even if you increase the speed, the charge will remain the same. Suppose it is a 5 coulomb charge, and whatever be the speed, the charge will remain as 5 coulomb. But the mass increases, the mass of an object increases with speed by the relation m is equals to m0 divided by root over of 1 minus b square by c square, where m0 or m0 is the rest mass, b is the velocity at which the object is traveling, and c is the speed of light. Okay, this is a relativistic formula that when we are traveling close to the speed of light c, then our mass increases. The faster we travel, our mass will increase. Okay, this is a relativistic formula. Now the third property, or we can say the third difference, is the charge is quantized, that is q is equals to Ne, but the quantization of mass is not yet established. Okay, means 1 electron, 2 electron can vary, but mass 0.1 gram can also vary, 0.5 gram can also vary, 1 nanogram, 1 milligram. A object can vary by this mass. Okay, so let's have a look over this table once again. Charge can be positive, negative of 0, but mass is always positive. Charge is independent of speed, whereas mass increases with speed. Charge is quantized, and quantization of mass is not yet established. Thank you. This was for today's video. Please like and subscribe my channel.